refresh everything that went through yesterday, is when you have sine or a cosine graph, which they're all periodic functions. They repeat themselves after a while. And the reason that they repeat themselves is if you follow your ordered pairs as you're going around, they just start over, and then they start over, okay? What's happening with that A value or that B value is just changing the rate at which they are repeating. They could be repeating at a longer duration, when the period is longer than a normal 2 pi, or it could be repeating quicker when the period is less than 2 pi. That A value, your amplitude, just tells you the height at which it's going. You see this a lot in sound waves. The louder the sound, the higher the spikes as they go through. That's what's occurring. They all pattern themselves. They all pattern themselves off of the generic function. Off of, sine starts at 0, goes to 1, goes back to 0, goes to -1, comes back to 0. Every single one of those, that's how these points work themselves through. It's just a matter of scrunching it, lengthening it, making it fatter, whatever. Finding the ordered pairs is just built off of working with your period values and your amplitudes. And it's very, very, very easy to do. It's the same process each time, whether it's a sine, a cosine, and then we talk about tangents tomorrow. It's the same basic principle. What we're going to do today is do a couple of these, and then we're going to do some shifting. So is there a specific? I hope. Is there a specific you want to look at, and I'll walk you through it, or do you want me to just kind of? Did that kind of help?
Yeah. I just don't know, like how are we supposed to know when the wavelength is supposed to be like shorter?
When your A value is large, your A value is large, that means it's spiking higher. When your B value is smaller, closer to 0, it's longer. Because you're dividing by your period, you're dividing by your B value. So if your B value is a fraction, your period has been extended. If the B value is larger, the period is shortened. Does that make sense? Izzy, you might have a specific.
I have like kind of the same thing as him. Like even though the A and B values are like going up and down, if you were to draw it to scale, you tell the difference. But for like our homework, it's fine if they all look the same.
Yes, and I was hoping that you would do that because I don't want you guys to mark off all these points in here, because what we're looking here is these points that you started with, 1, 2, 3, 4. These 5 points are what we call critical points. I don't care where they are as long as they're there.
Okay, but they should be like looking the direction the same because
They should. Okay. What's up?
20 was a tangent question.
I realized that when I was looking at it. Don't worry about it. Yes, ma'am.
Okay, so I'm just a little confused on the period stuff.
Okay.
Like when you put like B underneath, and sometimes B will have pi and sometimes it won't.
And that's okay.
It's fun to put pi and when not to put pi.
If B has a pi in it, you keep pi in it. If B doesn't, it doesn't. All that means is that your period, instead of having a pi in your period, it doesn't.
And so it doesn't matter if it doesn't have pi?
No. Not at all. It's there to annoy you.
With like the unit circle.
Yes. It's just there to annoy you. That's all it is. That's all it is. Which one was that?
There's a couple, there's just like went like back and forth whether I had a pi.
30. I think 30 did that, right? You had to do 30?
We'd have to grab it.
Oh, it's just matching it out? Okay. We had to graph.
41.
All right, let's look at 41. Okay? Ben, did you have a specific, or can I go to 41?
Actually, this one will answer my question too.
Perfect. Let's just walk through 41 together. Now, when I start these problems out, you probably pick this up from the video. Label everything you know. What's your A value? What's your B value? Therefore, you can figure out your amplitude, your period. A is 1/2. Your B is pi over 4. Okay? Which means my amplitude is 1/2. My period is going to be 2 pi divided by pi over 4, which is 8. Okay? So from there, I now know everything that I need to know to graph this. All I do is just make a little chart. There's my 0. Out here is my ending period at 8. Yes, ma'am?
Is
Yes.
that just between 2 pi? Or
Yes.
Is it between okay, so you only had to do like half
No, what happens here is this one rotation of this occurs in its period, and its period value is 8. So you're still getting, it just happens, this one is one that would be lengthened out, if you will. It's just a longer, it's a longer duration of the period. That's all. When it says within one cycle, that's what all of these are. You're just gonna go all up and down for all of these. One revolution, if you will. That was a random dude just there in the windows. Did you see that?
I could hear it. Yeah.
Okay. So what's halfway between 0 and 8?
4.
Okay, what's halfway between 0 and 4?
2.
What's halfway between 4 and 8?
6.
That's how you get your point values. That's all that is. Okay? And when those critical points become fractions, it's just as easy. What you're gonna do is you're gonna take halves. You're gonna multiply things by halves each time. What do you want? You can't have either of those. Joke.
It's all right.
Hey, tell the pre-calc's not that bad.
Pre-calc's not that bad.
Are you being honest?
Good luck.
Thanks, jerk. And now, your A value is what?
1/2.
1/2, so it's right here. And then the opposite of A is negative 1/2. That's all you have to plot out there. Now it's just a matter of matching up points. It's a sine graph. Sine always starts at 0. So it goes 0. And here's your graph. And that's it. Okay. Those are your 5 critical points. As you go through this, if you want it, one thing that'll probably become a little bit easier to do for when you start doing shifts is to list them. I didn't have you guys do that yesterday because it's easier when we start doing shifting things, H's and K's, to have the list because then you can add your H's and K's to know where things are going to go.
Well, we're not doing that right now.
We'll do that in about 10 minutes.
Okay, but don't put it in right now.
Okay.
because Otherwise, I'm gonna think I was wrong.
No, I'm just
Then
making sure
start
you're
doing it wrong.
I'm guessing tangent will have a different starting point.
Tangents a little bit weird. We do tangents all by themselves. Come on.
Okay, so I guess my question was, how do we know if it goes from like through 2, through 4, through 6, through 8? Like instead of like skipping over.
Yeah, I don't know. What do you mean?
It's like a line. How do we know? Like how will we know that it goes through like 2 zeros and then go and come back to close?
Oh, how do we know it's not just going to here? Okay. What happens with sine or cosine, any of these trig function graphs, is that a standard y equals sine of x graph, if you follow your unit circle, and you put in your critical points here, and these are your quadratic values. Do you agree? The sine value at 0, the y-coordinate on the unit circle is 0. Okay. At pi over 2, it was 1. At pi, it was here. Here, it was down at negative 1. And it came back to 2. If you wanted to get really fancy, you could go through and get all your other ordered pairs here and here as they're increasing, and then as they're decreasing, as they're, you know, all these curves. Oh, wow. I can't draw very well.
That was a nice one.
That was some nice.
Better-ish.
In our class.
What's happening is that these aren't linear. Okay? There's always a curve as everything's going. Okay? If you plotted all the points within all the different degree measures and radian values all throughout between 0 to pi over 2, you'd see them not in a straight line, but they would be curving as they're going. And then it comes back down because think about what the sine value is as it gets to pi over 2, then it's just all the repeats back down to 0 because sine is positive in both first 2 quadrants. And then it switches to the negative values and it repeats itself coming back up because of the 3rd and 4th quadrants. It's the exact same thing with cosine, except when cosine is when it's the cosine of 0, it starts at 1. And it does the same cycle. And it just follows itself through. These critical values, those 5 points, 0, pi over 2, you're out through your quadrantals like that, those values are your starting points, if you will. That A and the B are multiples, they're like factors. What are you multiplying it by to raise it? What are you multiplying it by to lengthen it or shorten the period to make it cycle quicker? That's all that is. It's like, bless you. It's like working with a similar triangle, and it's a scale factor, if you will. Okay? These critical values is how it starts. All right. Ladies.
Can we do 33?
Sure.
Is this the underwater excluded?
I'm confused about the machine.
Oh! Yeah.
Okay.
And your score.
So let's see. We do 33 first, and then I'll go to that.
Starts at A, was using matching graphs, then goes to 0, then negative A, and then 0.
So we have a cosine graph. Y equals cosine of 1/5 x. What's your A value?
1.
A is 1. What's your B value? 1/5. So your amplitude is,
1.
your period will be
10 pi.
10 pi. Good. The reason it's 10 pi, it's 2 pi divided by a fifth, multiplied by the reciprocal, and go. So as you start to plot this out, what's my ending point?
10 pi.
What's halfway?
5 pi.
What's halfway?
2.5 pi.
5 pi over 2, or 2.5 pi, either one is okay. And then here it's,
7.5.
So you don't need fractions, you can use decimals.
I would prefer fractions,
Okay.
okay? You're just multiplying by
I
half.
figured out, but
Yeah, but if you're really bad at that,
you decimals are
babies. I don't know. I normally go all fractions here. Your A value is 1, so that doesn't change. This is a cosine problem, so you go back to the idea when cosine of x is 0, what is the answer?
1.
1. So what you're doing here is you're substituting in 0 for x. Well, 0 times a fifth is 0. Cosine of 0 is 1. 1 times 1 is?
9.
So it starts here. If you substitute in here, you get 5 pi over 2 times 1/5 becomes pi over 2. Cosine of pi over 2 is 0. When it's doing it's multiplying by that scale factor. Your B value is some scale factor. So it just works its way down and back up. And there's your cosine graph. Okay?
How do you get 10 pi again?
10 pi is gotten by, your period values is always going to be 2 pi over the absolute value of the B. So this is 2 pi divided by 1/5, which is 2 pi times 5. Okay? Yes?
Do we have to do like all the math, not like what you just did, but before that? Or can you just assume that it goes from like above the x-axis to the x-axis below to the below?
Well, you should know that. I'm really not doing any math here at all, because I know that this cosine will always start at the A value, no matter what it is, whether it's a positive A value or a negative A value, which we'll talk more about today. It just means it's going in a different direction. That's all. And those are how it works. It starts at the A, 0, opposite of A, 0, and A. Works every single time.
Okay.
All right? There was a matching graph. Which one did you want to look at?
First four.
Yeah, maybe almost. Because they go like in between.
I didn't even do the magic.
Well, we know that it's not C or F.
Yes.
Yeah.
Those are tangents. So if you chose C or F, you're wrong. What was the first we had to do, 17 and 18?
Yeah.
All right, so 17 you have an A value of 2 and a B value of 1/2. That means your amplitude is 2, your period is 4 pi for a sine graph. So that means that your sine value would start at 0, it would go up to 2, and it would end again at 4 pi. Looks like B to me. Okay? Same idea with cosine. If you look at amplitude of 2, period of 4 pi for a cosine, isn't that E? Right below it?
Yeah.
Okay. And then we had what? 19? Yeah, I didn't mean to I actually put 20 on there. It's my fault. 21 would be 2 times cosine, so your cosine value amplitude of 2, but your period in this case is going to be pi. So cosine value that starts at 2 and cycles itself fully within 1 pi would be at A. Okay. What happens here is that they're just showing multiple revolutions of one of them. I'm only going to ask you guys to give me one cycle of whatever we get. Okay? I only want one cycle. Okay?
Yeah.
What's that? Good. There's no reason to go multiple cycles. There really isn't. Okay? I don't think you'll ever have to do more than one cycle in pre-calc anyway either. All right? Let's do this. Make sure your names are on that. Send that up, and let's start talking about shifting. We're going to shift sine and cosines today, and it's going to be it should be relatively easy. It's in there or not. Did you guys get your gang signs? Get it? You don't get it?
I get it.
Forgot Carol's grade.
Oh, that would have been awesome. That's a good idea.
I had no idea. Right when I saw it on my face, I knew it was coming.
That is awesome.
I can tell this is going to be
Anyway, so what we're going to do today is we're going to shift these. We're going to reintroduce.
It's okay, don't be fine.
It's okay. We're going to reintroduce AHs and Ks. All right. All right. What's going to happen here is we're still going to work with your horizontal and vertical shift. It is so similar to everything that we have been doing. The process to set these things up it may seem a little tedious, but if you follow the way that I go through these and you replicate the scenarios each time, it's really easy. Okay. There's not a lot of craziness. There's not a lot of curveball or anything to these things. It's just a matter of being able to identify an A, H, and a K, your B value, and plotting some points. So remember, your K value is your vertical shift. Your H value is your horizontal shift. The H value will always be pulled into parentheses. The K value will be out of the parentheses. This book does tend to put the K value in front sometimes instead of tacking it on in the back. What we're going to do is we're going to plot the parent function, what you guys did yesterday with the A and B. And then to those points, we're just going to shift them up, down, left, right. That's it. It is ridiculously simple. All right? Basically, yeah. I have no doubt that when we do a couple of quick examples, you guys, yeah, this is done. One thing I do want you to remember is that in this case here, we could have a negative A value. That just means when you're starting a sine graph, instead of starting at, when you start at 0, instead of going to the positive A, you would go to the negative A. If you're in a cosine graph, instead of starting at positive A, you're starting at negative. It's just completely reflective, okay? I don't think you guys you didn't have any reflections yesterday. I might have talked about it, but I don't think we did any reflection, okay? A lot of this is pretty stinking simple. So,
One of the problems was we did one of the notes, like in the notes, there was like
Oh, yeah?
we had a negative.
well, there you go. So this is going to be old hat. Jump right into it. So I have y equals -2 plus 3 times the sine of 4x. What do you think I'm going to do first?
Find your A, B, H, and K.
Find your A, B, H, and K. Very good. So my A value is, B value is, H value is, bless you, and K value is. Okay. Now, we know that when we graph the parent function here, what are we going to have to do to it? Where? Yes, we're going to have to move it. Do you like to move it?
I do.
Yes, ma'am.
Why don't we find the amplitude?
I'm not that far yet. Jeez. What I'm saying here is that by knowing that you're just, in this case, we're just going to shift the graph downward. When we go to plot our graph, you know, yesterday we just kind of make that little T-chart to the side. What we're going to do is going to kind of overemphasize some of the axes. Very easy. What's your amplitude?
3.
What's your period?
Pi over 2.
Good. So now I know that my graph is going to have to be moved downward too. So what I'm going to do is kind of over-exaggerate the lower end. You okay with that? Because I know that with my amplitude being at 3, now my highest values, when I shift, it's going to be at 1. But my lowest value would be at -5. You okay with that? I'm just kind of getting in the habit of thinking about where it's going to go. When we shift things to the left, I might make this longer going over this way. You know, just little things. It's subtle, and as you get better at these, the more you do, you pick up on the little tricks. First thing I would do is put in my period value. Since there's no H shift, I can set it. Fractions. What's half of a half?
4.
Okay. What's half of a fourth? And what's 3/4 of a half? Oops. I don't know if you guys all heard what I said there. What was 3/4 of a half? 3/8. What I'm doing there is I know that my critical values as they plot themselves through full cycle, half cycle, quarter cycle, 3/4 cycle. By taking 3/4 times 1/2, you can multiply that fraction relatively easy in your head instead of trying to figure out the halfway between a quarter and a half. All right, that's just one way of doing it. Guys,
Okay, so for me, like yesterday when we were doing this, I took so long to figure out why it was 3s. So would you mark this wrong if we changed pi over 4 to like 2 pi over 4 or 2 pi over 8?
no.
Okay.
If it's helpful to do that as you're plotting through, it's fine. Just be careful when I ask for these listed out as you're clear, the actual ordered pairs, make sure they're simplified out.
Okay.
Okay. Now I know that my amplitude value was at 3. And now I just plot it. Sine graph, so sine always starts where? 0. Goes to its, goes back to 0, goes to the opposite of A, and back to 0. What do you think we do when we have?
Line.
Very good. It's a parent function. Parent functions are dotted.
Erasing some of the lines.
No, Colin, don't even bother, man. Just do this. If you forget, it's okay. Go back and say it's dotted. I'm all right with that. All right? Serious. It's not that big of a deal. Okay? Or erase it. Yeah, or go back and just erase little bits. Now, we know that your parent function, I'm just going to kind of go the long way here, was at 0, 0, pi over 8, 3, pi over 4, 0, 3 pi over 8, -3, and then pi over 2, 0. Those are all my parent function ordered pairs. To each of those ordered pairs for the shift, remember how we did this with logs and exponential? We would write out what your h and k is going to happen. Sometimes it's easy for people to be able to see that because it's easier to write your ordered pairs, especially when we have h shifts with fractions. It'll be a little bit easier to add and subtract. Remember, your shift will be no shift on the x, but it'll be a y minus 2. So each of these ordered pairs, the x values stay the same, but the new one is at -2, pi over 8, 1, pi over 4, -2, 3 pi over 8, -5, and then pi over 2, -2. All I'm doing there is just relisting my new ordered pairs. Pretty easy, right? What's that? And I just plot it. You're done. So instead of starting at 0, start at -2. And this one is solid. Like I said, graphing of trig functions are a lot easier than working with trig.
Oh, yes.
Not gonna do what? We are working with trig.
This is like easy.
Okay.
I have a question about the age. If the points are in pi, will the age most likely be in pi? Or will it always be a whole number? Because having to deal with those being pi, but shifting in a whole number.
A lot of times it has pi.
Okay.
A lot of times
And
it
then
does.
there's just a whole number and it'll be like a whole number.
It's kind of a pain sometimes.
Yeah.
Let's try another one. Let's see if I have, let's go right to one of the hacks there. We'll go right to that. What's that? Or you want that back up? I'm sorry. Oh. So we're going to go right into a horizontal shift. There's no vertical shift in this case, so it's just horizontal. And the reason why there's no vertical shift is?
Because there's no K.
Correct. What do you think I'm going to do first? Oh,
Label stuff.
label stuff. So 2 pi divided by 2/3 is?
6 pi.
3 pi.
To be 3 pi.
Yeah.
Okay. So you get 3 pi for your period. Your h value, is that going to be a negative pi over 4 or a positive pi over 4? Positive pi over 4, very good. And there's no k value, so. All right. Plot your parent function. We know that your horizontal shift is going to move to the right pi over 4, so I don't have to worry about placing my y-axis anywhere different. But instead of putting 3 pi at the very end, I might move it inward a little bit so I have a little bit of more room on this, to the right of it. Does that make sense by being able to leave yourself a little bit more space? And now it's just a matter of tacking in your spots. 3 pi, 3 pi over 2, 3 pi over 4, 3/4 would be 9 pi over 4. It's 3/4. What's 3/4 times 3?
Magic.
It's magic, you're right. So those are my points. Oh, if we also have 0. Is that a big?
You need a label 0?
No, you don't really need to, because you're plotting your value at your amplitude here. So you start at 2 because that's your amplitude, because it's cosine. Where does the next point go?
0.
The next one,
Opposite of A.
back to 0, and back to here. Here's 0 and 2. And then on my new ordered pairs, all I have to do is add in a 4th to each one of them. So what's 0 plus a 4th?
1 and 4.
5, 4.
Oh, I see.
What? 0 plus a 4th is 5/4?
I say pi over 4.
Oh, I thought you said 5 over 4. I'm like, what?
Nah. I was confused when we got quiet and they were looking at us like, what?
1/4 plus 3/4 is?
What?
Pi.
Oh, pi.
Yeah, and what I'm doing, a lot of times when I'm adding with the pi values, I'm just leave pi out for the time being, just to work with fractions.
Okay.
3 over 2. That's the same as,
6 pi.
6
6 pi over.
so what's 6 over 4 plus 1 over 4? 6 So do you see how the working with fractions really isn't that bad? You're not going to get that crazy of values here, guys. Okay? Then you have 10 pi over 4, which is 5 pi over 2. And then 3 1/4, to bless you, who would be 10 pi over 4, I believe? No, 11. 11. Math. No.
Wait, I don't even know.
13. Math is hard. So here's the thing. I don't know about you, but I'm really not going to be measuring out quarter values all the way through. I just listed all of my correct ordered pairs, so can I just say here, 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 and here?
Good, yeah.
All right, I did.
Alright.
Oh, I forgot to make my dotted line.
I got it.
So the new one I just make my solid line, just move all my points over. And done. I'm done. What I want you guys to be able to do here is, I know some of these graphs can get really messy with all the different fractions and all the different ordered pairs and stuff. Get in the habit of listing out your ordered pairs on your graph like you would for your parent function. When you go to do your shift, obviously if there's a vertical shift, you mark it up and down. But if it starts to get messy, like something like this, because it's all kind of tacked in a little bit, if you don't label these, I guess it's really not the end of the world, because it can get kind of messy, because you're telling me what they are here. All right? I want you to give me parent and shift, because that's what we did with, I think that's what we did with
Yeah.
one of those weird things, right?
To give you the ordered pair for the
Yes,
parent.
please. Order pairs for the parent and the shift, because that way it's, by doing it that way, it really forces you to work the fractions the right way. Oh, and don't use your calculators, because you're not going to get one.
What would you
You could do like 3 over 4.
I lied.
Okay.
When's
the next time we actually gonna use a calculator?
I don't know. Sooner or later. Why do we even have them? We use
Do
them.
math.
Because there are some things you need to use calculators for.
Guess what we're doing?
Did you like my notes for what we're doing this week?
Quiz on underwater basket reading.
Underwater basket weaving. I think that sounds like a very good quiz.
No idea what that is, but it'll be better than my last one.
It's basket weaving underwater, duh.
It doesn't say that you're necessarily underwater. The baskets can be underwater.
I'm nasty. I'm a stupid ass.
So let's do a sign graph that has both the horizontal and a vertical shift. There's no A value. Or B. Kind of made it easy on this one. There's no A. Your A value is 1. Your B value is 1. So your amplitude is, and your period is. So this is easy when it starts up like that. Okay. I know that I have an H of what? Very good. And a K value of
-2.
So we know that this graph's going to have to move to the right and down. You okay with that?
Yeah.
So when I'm going to over-exaggerate my graph again. I'm going to bring my x-axis up a little bit and extend it out and put my 2 pi here. Remember, the reason that I'm extending it outward is because I'm going to have to move that 2 pi value eventually to the right a bunch more. That way I know that I'll have a little bit of space. All right. What was that? Foreshadowing, I believe?
Yeah.
Look, a literary term.
Sounds good.
Critical value should be easy when your period is at 2, I hope. Hey, let's mess this up real quick. Let's say we have an A value of -1. Just because we haven't done an opposite one, let's just make it a negative.
I literally already.
Well, cut it out, flip it upside down on paper, and be fine.
So we just put.
I would say it's negative sign, okay? Just so that you get the idea of what happens with a negative A value. That's all. Because I know we're running a little short on time. That way you see it. It's not difficult. It works the same with cosines. So we're just saying our A value is -1. Remember, your amplitude is still the absolute value of it. What happens here is that instead of starting at your A value, or so when you go to 0, you go to your A value. We go to -1 and then back up. So it's just it's an inverted, it's been reflected. That's all. It just tells you to go the other direction. That's all that means. So when you have a sign value with a -A, it just means instead of moving up to your amplitude, you're moving to the opposite amplitude first. That's all. Your amplitude is still 1 because it's still the height value. And now to all these values, we just have to shift them. Ordered pairwise, shouldn't be that bad. 0, 0. Pi over 2. -1. Pi, 0. 3 pi over 2. +1. And then 2 pi back at 0. To each of these, we have to move them to the right and down. So this can be an x plus 3 pi over 2. And then y minus 2. So my first ordered pair will be at, change my color, 3 pi over 2, -2. Where's your next one? 2 pi and -3. Next one would be at 5 pi over 2, -2. 6 pi over 2 is 3 pi, -1. And then that would be for 7 pi over 2. So we have 3 pi over 2, 2 pi over 2, 5 pi over 2. It's nice when they're all in a row like that. The advantage of listing ordered pairs helps you tremendously when you go to rewrite. Now in this case, I would want to rewrite all my stuff out on my axis because I can fit it all. So working ordered pairs first just makes it easier. So we start at oops, I put it in the wrong spot. There I go.
You go. You type.
Oops. Forgot that we had an A value. -2, -3. So that's all I have to put in there. So we go to -2, -3, -2, -1, -2. It may not look perfect, but it does look ridiculous. But you know what? It doesn't matter if it looks ridiculous because you told me what the ordered pairs were. Ordered pairs rule. Okay.
All right.
Not bad? Let's do something. Like 3. Let's see. Let's do.
Wait. You just have to do this?
Oh. Let's do 36 through 42, and then 50 and 51. Okay? I'm figuring that out. Relax. I just had to figure out what page number it was. 845. Oh. Sorry. 53. Yeah, and 53. I want to see if you guys can write the graphs. So it's 845.
It's actually 10:10.
Gee, where'd you get that line from?
I don't know.
Remember,
50, 51, and 53 are actually telling you what the graph is being translated to, so you have to identify the AH and K, or AB, H, and K out of that. See if you can write the equation. Working backwards out of it.
Mr. Murphy, could you go back to